ecosystem. So we're not changing up our essential question or our I can statement today. We're just going a little bit deeper into invasive species today. Before we do that, I have been grading homework assignments all weekend, and there were some things that I noticed people were getting wrong, and it has to do with this energy pyramid that we talked about a couple weeks ago. And so the question in the homework assignment was, if you were to go to Yellowstone, what trophic level would you see the most of? And a lot of people got this one wrong. They thought it'd be primary consumers or secondary consumers. But if you were to drive into Yellowstone, what trophic level that you see here, would you see producers, primary consumers, or secondary consumers the most? Would you guys drop it in the chat? So if we were to drive through Yellowstone together, we got on the Magic School Bus and went to Yellowstone. Yeah, we would see the producers, right? We would see all the trees and the plants and the sagebrush. We wouldn't necessarily see a ton of primary or secondary consumers because there aren't as many of them, right? Because remember, there has to be more producers available for the primary consumers that are there. And there has to be more primary consumers than secondary or tertiary consumers. So the other question was, which trophic level would you see the least of? And that would be your tertiary and secondary consumers, because there aren't that many of them, right? The ecosystem cannot hold thousands and thousands of grizzly bears. There wouldn't be enough food for them. So when you drive through Yellowstone, if you've ever done it, you would see a lot of plants. You might see a herd of buffalo or a herd of elk or some antelope, because there's more of those than there are grizzly bears, wolves, cougars, and things like that, because of the energy pyramid. And then the other question that some people were getting wrong, and so I wanted to just, there's going to be a question like this on your test that's going to ask you if you have a certain amount of calories in the producers. So I gave you guys just an arbitrary number, 14,870 kilocalories in the producers, then how much energy is going to be available to the primary consumers? So if you guys could, I'm seeing some people in the chat writing. So if we go from, if we have 14,870 here, if we go up to the next level, only 10% goes to the next level. So one way to do this is a math problem, right? If we have a decimal point right here, if we move the decimal point one number over, we get to 14,887, and that is correct. So those of you that are putting that in the chat, you are right. So then how much would be in the secondary consumers? Using that same math equation, we're moving the decimal point over 1. Yes. So it's just a 10% is all that goes to the next level. And a lot of people are getting this wrong on this assignment. And so there will be a question. You will see a question just like this on the test on Friday. So I just wanted to make sure that we clarified that. All right. I promise we're getting to zebra mussels today. Oh, here they are. Okay, so today we're going to take a look at another invasive species called zebra mussels. And I know some of you did some research on them for your assignment number 9 that was due yesterday, because I've been starting to grade those. So some of you have already looked up some things about zebra mussels. I wanted to tell you a quick personal story about zebra mussels and what they've done to a lake that's very special to me. So my family has a cabin up north on a lake called Lake Mary. And for years, I've been going up there my whole life. And we have a native clam that has lived in the lake for as long as, I don't know, as long as I know, and probably longer than that before me. And a couple years ago, we started picking the clams up and noticing that there were all these mussels connected to the clams. And what we also noticed were the clams were losing their color. So like they're usually a dark, rich brown color, but the clams were pale, like almost turning white. And so at first I didn't know what these things were. And so I brought them to our lake association president and they said, oh my gosh, we have zebra mussels. And they started to freak out. We have a boat launch right next to our property. And so people were bringing the zebra mussels in on their boats. And what they were doing to the clams is they were attaching themselves to the clams right by where the clams feed. So mussels and clams both inhale water and take the food. They filter the food through, it's called filter feeding, and then they exhale the water. And these zebra mussels were putting themselves right next to the siphons of the clam and eating all of the clam's food. And so the clams were all losing their color because they weren't getting any nutrients because the zebra mussels are eating all of them or taking in all of the water. So that was a problem for the native clams. For the people in my family, these are really sharp. And so we have had multiple people over the last couple of years who have cut their feet in the lake. And dogs have cut their feet. So they're not only slightly dangerous to those of us that like to recreate in the water, swim, ski, whatever. They're also harming the native clams. And then they also have the ability to clog up pipes and drains and anything that might be any kind of pipe or drain that runs into the lake or out of the lake. These can fill those up and clog them up. Now, one thing we've noticed, so we've had zebra mussels for the last 3 or 4 years. I think it's been 4 years since the first ones we've seen. So we also this year started noticing that there are way more crayfish in our lake now. And we were wondering about why are there more crayfish now? And so some of us have gone out snorkeling and we've found the crayfish are eating the zebra mussels. So the crayfish have found a new food source in the zebra mussels. And so they're eating them. And now the crayfish population is gone up because of the zebra mussels. So there's been a huge change in the food web in our little lake. Where this clam population is going down while the zebra mussels are going up, but the crayfish are now finding a new food source. So lots and lots of interesting things are happening with this little, I hate these little things, but they're very small, but they have a huge impact. So we're going to watch a quick video. And then I'm gonna start your homework with you, get you started on that. And because we've learned that showing videos for my computer is kind of hard, if we can turn off our cameras, for those of you that are showing your camera, and then we can watch this. Silent invaders here. All right, here we go.
There's something therapeutic about the sounds of water splashing against the shore, but all is not well beneath these tranquil waves. Invasive zebra and quagga mussels are infecting many of our lakes in ways never before experienced or even imagined. Thousands of these invaders drop to the floor each time commercial fisherman Jeff Weeborg releases his gill nets into Lake Michigan.
It's hard to imagine, but our scientist at NOAA who studies life on the bottom has estimated that there are over 4 quadrillion mussels on the bottom of the lake.
These destructive mussels blanket the floor of big and small lakes alike. They have invaded 20 states, lurking in hundreds of inland lakes and 6 major rivers. And they stick themselves to everything.
So if you take a look at a pipe that mussels have entered, now you've got a problem.
Utility pipes and machinery often get clogged with massive amounts of sticking mussels, and it's costing us millions.
Right now is probably between 15 and 20 million a year to control them at the pipes.
But that's only part of the problem.
They can change the ecosystem in ways you don't want the ecosystem changed.
Hungry zebra and quagga mussels are literally sucking in plankton, a critical part of the food chain and necessary for the survival of game fish. And the mussels have a voracious appetite.
A zebra mussel the size of my thumb can filter a liter or roughly a quart of water a day.
The only way these invasives can get into a lake is when a recreational boater or angler inadvertently puts them there. When traveling from one body of water to another, they either forget or don't know how to rid their boats of microscopic larvae.
Those larvae are virtually invisible to the naked eye. There's about 100 zebra mussel larvae in this vial.
The only prevention method is to clean, drain, and dry your boat every time you take it out of the water.
Make sure that you don't move water of any kind from one body of water to another. That means the bait buckets and the live wells and anything else that might be contained in your vessel.
It's the only way to stop these invasive aquatic hitchhikers, known as the silent invaders.
All right. Okay, so that was a little bit more information about the zebra mussels and some of the problems that they cause. And by the way, that asking boaters to dry and wash off their boats every time they leave. If you ever go to a boat landing, they'll say to do that, but it's just for some boaters, it's just more than they're willing to do. And that's how the zebra mussels got into our lake, was because of that boat ramp that was right next to it. And actually, when we asked people across the lake on the other side if they had zebra mussels, they did not. So we were having them on our property because we were so close to that boat launch, because that's how they get into the lake. All right, so let's open up your assignment for today, number 11. I'm going to share with you my iPad here. So graded practice number 11. So this starts off as a reading, and because of time, I'm gonna kind of skim through it with you and just talk to you a little bit about how the zebra mussels got here in the first place, because they are native to the Caspian Sea, which is near Iran and Russia. So they come from a place where they're not as invasive, because they have predators, and they can't they don't do as much damage there. But how they got here was they were carried in ballast water. So when big ships come across the ocean carrying cargo, they have to take in water. It's called ballast water, in order for the ship to travel correctly on the water. So it has to, when they're empty, when their cargo hold is empty, they need to take in water to keep the ship stable, and also to make sure that the propeller is in the water and the rudder is in the water. And so they'll fill up with water And then they'll travel with that ballast water until they get to where they're taking in their cargo. And then when they're loading up their cargo, they drop the ballast water, and whatever's in that water goes with them. So that is how they believe that the zebra mussel got to the Great Lakes, is by being carried in that ballast water. And you guys saw that little tiny vial that the guy had that said there's 100 zebra mussel larvae in here, that they're really, really tiny. So you wouldn't even be able to see that they were in that water when they were being taken on. So the next page talks about some of the problems, the impacts of the zebra mussels on native ecosystems. So you can read this. And in fact, if you haven't done your homework assignment that was due yesterday, this would be a great resource to find out some information about what they've done to the native populations. And then, like we talked about, some of the impacts they have on humans, are cut up feet, filling in pipes and causing damage to different companies that use the Great Lakes and have pipes that go in and out of them. But today we're going to focus on how they have hurt a native organism in a lake called Lake Terra. Oh, sorry. I meant to practice this. Trasimeno. I think that's correct. So we have some graphing that we're going to do here. So this graph is already set up for you. There's a couple things I want you to notice. The years are down at the bottom, 1960 through 1988. Okay, so every line here is a year, but they only give you data every 2 years for this first set of data. And then the number of mussels, so the population is on the y-axis, and this is the number of mussels per meter squared. Okay, so a meter, like if you think of a meter stick, so this is how many mussels you would find if you had a meter square. So that's not a very big space. Okay, these mussels are very tiny. So that's the measurements here. So the first thing it's asking you to do is to make a line graph of the data using a black pencil. Okay, each line on the Y is 200 zebra mussels. Label the black line zebra mussel, and each line on the X is a year. So we're not going to use the whole graph, right? That's what the directions are telling us. So it's asking you use a black pen. And so for the first two, 1960 and 1962, we had 0 zebra mussels. So our first two dots are going to be at the 0 mark. And by the way, each of these lines equals 200 zebra mussels. Just so you know, we go from 0 to 200 to 400 to 600. And then in 1964, there was 203 zebra mussels per square meter. So somewhere right above the 200 mark. And then in 66, there were almost 400. And then in 68, there was almost close to 600. So 575 is going to be about right there. And then in 1970, there was 701. So remember, this is our 600 line here. So it's somewhere in the middle of these two. And then 72, we had just above 800. And 74, we had almost 1,000. And in 76, 1,205. So right above the 1,200 line. I'm just going to do this so I can see it. All right, and because this is a line graph, you should connect these dots, right? So you're going to go ahead and connect them. Oops, that was a horrible line. Oopsie, 0. And if you haven't done much graphing on notability yet, this is really good practice because you're going to be doing a lot of graphs during the cells unit, our next unit. All right, and it told me to label this zebra mussels. I'm going to make it big and then use my scissors tool. All right, so we didn't use the rest of the graph. It didn't have data for that, but when we go down here, you're going to ask, you're going to be asked a couple questions. So the first one is asking about what year would you suspect that zebra mussels were introduced into the lake? So when do you guys think they were introduced into the lake? What year? So in 62, there were zero zebra mussels per square meter. And then in 64, there was 200. So yeah, 60, maybe 64, maybe 63, right? Because remember, there's a year in between here that's not listed. So it might have been in 63. Oops. I'm sorry. I don't know why I have my arrow in the wrong place here. I would say 63, probably, because they had to have some time to reproduce and so that there were enough to measure 200 per square meter. Okay, so the next thing it's asking you to do is to sketch a line on your graph predicting what you think is going to happen to the population during the 12 years after 1976. Use a red pencil to draw your prediction line and label the red line my prediction. Okay, so you are going to decide. This is completely up to you. Maybe you think it's going to do something like this. You're just drawing in a prediction line, okay, and writing my prediction on it. All right. After you've made your prediction, it's going to ask you to explain your prediction. So why do you think the graph is going to look that way? So you're going to write in your reasoning, okay? And then the next thing you're going to do is you're going to graph the actual data from 1978 to 1988. So you're just adding these zebra mussels to your graph. And you're going to notice either you were right about your prediction or maybe something happened that you didn't predict. So it tells you to use a black pencil to do the actual plotting here. So use a black pencil to plot the actual data. So you're going to go back up here. It might help you. I might do something like this. I might copy this and move it up to here so I can see this data without having to go back and forth. But you guys are going to go through and just plot the new data. And I believe it does something very similar to what I thought. myself. But then something happens that I did not predict in 84. This isn't the right data. But in 84, things start to change. There's fewer, it goes from 290 here to 2944 and then 2950. So something happens to the zebra mussels where they're not continuing in a straight line as I thought. Something happens to them around 1984. So you're going to answer a few questions about that. And how your prediction compared to what actually happened. All right. The last thing that you are going to be doing, so there's some questions for you to answer here. I'm not going to answer these for you. This is part of your assignment. But I do want to explain this next part where you're going further. You're going to now be looking at a native mussel that was native to this lake and what happened to it over the same time period. But I want to point something out to you here because this tripped me up when I did this assignment myself. They only give you the data every 4 years. Okay, so instead of giving you the data like they did with the zebra mussels up here every 2 years, they're giving you data every 4 years. Okay, so for instance, the first, I'll do this, and it's asking you to do the swan mussels in blue. See, it's asking you to use a blue pencil to plot them. So when you do the swan mussels, just keep in mind that it's every 4 years. So you're going to put a plot for 1960 is about 2000. And then your next set of data is not at 62, it's not till 64. Okay, so notice that this goes from 60 to 64. And the mussels didn't really change much then. So our next plot for 64 would be about the same. All right, so you're gonna plot what happens to the swan mussels as the zebra mussels go up like they did, and then answer some questions about that. And that is the rest of your homework assignment. So you're going to plot these points and then answer some questions, take a look at what the zebra mussels did to the native population, and that'll be it for ecology.